So problem 410, we're kind of back inside the life insurance setup for this example. So what is this exercise about? Assume that we are insuring a couple. So we have a couple here. So this is one person and the other part of the couple is here. And what do we do? Well, let this be person number 2 and let this be person number 1, right? So assume you're insuring a couple and let the remaining lifetimes of them be T1 and T2. So let's just let the remaining lifetime here be T1 and let the remaining lifetime here be T2. So that means that T1 years from now, this person will die, and T2 years from now, this person will die. We don't know if T1 is greater or T2 is greater. In fact, we don't know the values of T1 and T2. We only know that they are exponentially distributed. So T1 is exponentially distributed with parameter lambda 1, whereas T2 is exponentially distributed with parameter lambda 2. Also, it is assumed that T1 and T2 are independent. So the lifetime of person number 1 is independent from the lifetime of person number 2. Actually, in the real world, it's not exactly that way if they are a couple, because if one of them dies, then it kind of affects the lifetime of the other. I think that statistically in Denmark, if we have a different sex couple, so a woman and a man, then the statistics say that if the man dies first, the woman would live longer than she would have done otherwise. However, if the woman dies first, the man lives shorter than he would have done otherwise. Interpret as you wish. So, we assume that T1 and T2 are independent. What are we asked to find? Well, you pay benefits as long as both are alive. So what does that mean? That means if we are the insurance company, then let this be the timeline. Let's just assume that T1 falls here and T2 falls here. We pay benefits as long as both are alive. In this case, we pay until the first person dies. Boom. So this is how long we pay. So let X be the length of the interval of time where you pay benefits. So the way we model this is we say let X be the minimum of T1 and T2, right? Because if you pay as long as both are alive, then if T1 is the smallest value, then you pay for T1 years. And if T2 is the smallest value, so if number 2 dies first, then you pay for T2 years. So in case 1, find the density of X given as the minimum of T1 and T2. So what we want to do is find the density of X, right? And they give us a hint. They say, consider that the probability of X being greater than T is something something. So what we actually will need to do is, since the hint gives us this thing, we will kind of have to find the density based on this, right? And this is the survival function. So we just need to recall that the density of X for some value T is the derivative of the survival function with a minus in front. Or actually, by definition, it is the derivative of the distribution function, right? Which is then equal to 1 minus the survival function. And that is equal to minus the derivative of the survival function, because when we differentiate 1, we just get nothing. So it's really good to recall the connection between the density, the survival function, and the distribution function. So in A, we want to find the density of X, and something tells us that we will start by finding this, and then we will try to differentiate it. Put a minus sign in front. So in case 2, we pay as long as only 1 is alive. So what does that mean? That means that if we're looking at the same where T2 dies first and then T1 dies afterwards, then the difference from case 2 compared to case 1 is that it doesn't really matter if 1 is dead as long as 1 is alive. So then we will actually pay until the time where the last person dies. What does that mean? Well, that actually means that we need to find the density of y. So we want to find, we want y to be the length of time that we pay. We want to find the density of y defined as the maximum of T1 and T2, right? Because we pay until the last one dies. So here y is the maximum. And maybe we'll be able to use the same hint, maybe not. So that was just a reading of the exercise text with the relevant definitions written up. So look at the next videos for solutions. Oh yeah, just before we move on, let us just recall as well that if T1 and T2 are independent, that means that the probability of T1 belonging to some set and T2 belonging to some set is equal to the product of probabilities. And that might be pretty useful later on. So see you guys in the next video.